In this video, I want to talk about Prefect, which is a modern workflow scheduler that really celebrates the Python language. Prefect always had first-class support for Python, but it never really had support for Python notebooks. I suspect that one of the reasons for this is that notebooks like Jupyter, in the end, aren't stored as pure Python files, so you can see how a direct integration wouldn't be straightforward. However, these days we have Marimo notebooks, and these actually are stored as proper Python files under the hood. So I was wondering, what would a Prefect workflow be like if I try to combine the two? Can I now define a single Python notebook that can be made a production job very easily via something like Prefect? Well, long story short, yeah, you can, and the result really feels like an upgrade. You're able to get all the benefits of Prefect with your workflows, but you never lose any of the Marimo features like dashboards, debuggable views, PyTest support, and you can even build command line utilities in the same file that is also your production workflow. The goal of this video is to explain how you can set all of this up, but to fully appreciate how all of it works, I will need to do a bit of a deep dive and explain both of these two tools first. I'll start with Prefect and explain the problem that it solves, after which I'm going to explain how Marimo represents a full notebook in a normal Python file. After all of that, I hope to show you this one trick that suddenly makes it very straightforward to maintain a Python notebook that is also a proper Prefect job ready to be scheduled for production. Alright, so let's do a hello world of Prefect. I installed it locally using UV, and I can start a Prefect server by calling prefect server and then start. With that server now started, I can have a look at this demo file that I made, which doesn't really have an important workload in it, it's just really there for demo purposes, but you can see that it has two functions. There's one called concatenate, there's one called demo, and one function is decorated with this task decorator, and the other one is decorated with a flow decorator. These task and flow decorators, those are building blocks that come out of Prefect, and they give you a nice way to take a longer program, a longer job that's supposed to run, and to maybe chop that up into bite-sized bits. In this case, I'm keeping things simple because this one entry point, which is usually the function that's decorated with flow, that is really just using one function, this concatenate function, but it's using it a whole bunch. So first, I'm concatenating the string hello in Marimo, then hello in Prefect, then I'm concatenating those two together. I'm doing the same thing with goodbye in Marimo, goodbye in Prefect. I'm concatenating those two together. So as far as the order of things go, you can imagine that there's a bit of a DAG, a bit of a graph in which this concatenation function is being run over and over and over again. And Prefect is going to give me a nice way to keep track of all these separate functions that are running. And not only that, another thing that you can also do is add things like a retry mechanic. So this task over here, well, it's allowed to fail 10 times. And if it doesn't work for whatever reason, it's going to rerun. And to simulate this, I also added this random call over here. 60% of the time, this function is going to fail, but because I've got this retry call over here, the whole job should still run. So if I were now to just do UV run and run that quick demo.py file, tasks are running, there's some retry mechanics happening. But the one thing that's really cool now as well is that this is now also being logged in a database, and the Prefect server is also able to give me a nice view on what's happening. So what I'm going to do now is I'm going to immediately run this Python file, and then I'm going to go to the Prefect server that's running so you can see what happens live. So this is now going to run. I'm going to go into my runs tab over here. I can see this one thing that's running, and lo and behold, we can see that stuff is indeed running. A concatenation function seems to be running, and after two of them ran, another one runs. Some of these calls are longer than others. When I scroll down over here, you can also see that some of these tasks are being retried. And after a while, it's done. And one, I think, kind of nice UI feature, I can go to the cog over here and I can say, hey, I'm interested in seeing the dependency grid. So you can see that some functions call other functions. And alternatively, you can also just look at the temporal sequence, these steps that are happening over time. You can still see these arcs. And at any point in time, you can click one of these functions. You can go to that one task run. You can click that. And then you can see the logs for that one task. And in this case, you can very clearly see that we are dealing with a retry mechanic. It's failing a bunch of times, but then it's succeeding. But if we take a step back now, we hopefully also get an impression of what Prefect is able to do for you. Prefect effectively gives you a whole lot of accounting on your production Python scripts, you could say. You're able to decorate functions, which is a good habit in general because it gives structure to your program, but then you'll also get a lot of accounting that is very useful when you're trying to debug. You can see which function fails, you can also see when. There's all sorts of logging options. You can also run things concurrently. You can add workers to your heart's content. But the main thing that's important to know now is that by just adding a few decorators and some settings, you get a lot of good logging. And you can also configure Prefect in such a way that you get cloud resources to run those jobs onto. That's the problem that Prefect solves. And again, one of the things that I really appreciate about it is that you just have to write Python functions as you would normally, and you just have these two decorators, and then you get a whole lot in return. So it's not a lot of abstractions you got to learn or anything like that. You can just keep on writing Python functions. configure Prefect, and you're pretty much good to go for a lot of production work. All right, so that was Prefect. Let's now run marimo, and let me just first notebook.py. Let's just create a first notebook just to get a feeling of what marimo is like. And there we go. We're in a notebook. We have cells. We've got some auto-completion as well. I can create some new variables too if I like, and I can also add things together, and I get cell outputs. So far this might feel familiar and might feel very similar to Jupyter, but there are a lot of differences. I'm not going to go into all the details, but just to give a quick demo of what's different, right? One thing I can do is I can add a slider. This is a UI element. This UI element has a value, one that I can also show. So I could do something like this, where if I slide the slider around, you can see that value update live. And there's something very reactive about this. Something that makes marimo very different from other notebooks is that it can automatically detect where variables are defined and what cells then depend on a parent cell. In this case, I'm declaring a slider over here, and this cell is a child of it, you could say. And this can propagate. I can now say, hey, the value of that slider, let's attach that to the variable a over here. Let's run it. And then every time now that I change the slider over here, all these other cells update. There's a couple of really neat consequences in this reactive nature of the notebook. One of them is that I cannot define a variable twice. So in marimo, you can only have one and only one place where a variable is defined. And if that's not the case, there's just going to be an error in your face about it. And this prevents a whole lot of bugs. Similarly, if I were ever to maybe delete a cell, like the one that defines B, for example, then the notebook can also detect that a variable is missing, which again is something that prevents a whole lot of bugs later down the line. And this, again, is very different from Jupyter. In Jupyter, if you have a variable in memory, it can stay in memory even if you remove the declaration in the actual view of the notebook. So let me just undo a few things here. Let's add B back in as a variable. Long story short, marimo is different. The reactive nature is at the very core of that. But the main thing I want to zoom in on now is just what this looks like under the hood, because this is a Python file. So I'm back in my terminal now. I'm just going to open up that first notebook.py file, and then we can have a look at what's inside. So all the way on top, the first thing we see is this specification that's commented out. This allows you to define the dependencies for this notebook. And in this case, you can see that marimo is needed, but this is something that you could use together with UV to make sure that this Python file has all of its dependencies declared up front. And that way you can just run this as a normal Python script by calling UV run. That already is a huge feature. But the thing I want to just zoom in on maybe first and foremost is the way that these cells are represented. So again, in Jupyter, all of this will be a big JSON file. But what you can see here is that cells are not JSON blobs. They are actually Python functions. They are decorated Python functions, to be precise. They are decorated with this app.cell decorator over here. And you can see the body of the cell is exactly the same as the body of the function. It's just that this cell over here, it imports this marimo as MO, and we also see that it returns it. Then down below over here, we've got a different cell. We see this variable A over here that's defined in this cell, so that's also something that's exposed. And we also see that this cell needs this slider variable around in order to calculate A, so that is the input of a cell. And hopefully you can kind of see the DAG of operations here. Some cells are required to run other cells, and the whole point of marimo is to have the user define all of these cells, and then for marimo to figure out at runtime in what order things have to run, and it can then do that automatically if you like. And I should say, if you're dealing with heavy workloads, there's also a switch that allows you to do all this manually instead of having it run automatically. That's a bit outside of the scope of this video. The main thing that I want to zoom in on is that this is, in the end, still a Python file, and you can run this notebook as a Python script locally. However, under the hood, we are doing a lot of wrapping of our original code. So you can see over here, hey, I've got my marimo import over here, but that's inside of this cell. And similarly, whenever I'm doing anything with these other variables, all of that is happening inside of these cells. And when you look at that, you might wonder, well, how can I actually get Prefect to integrate with this? Because naively, one thing you might try is you could say, well, from Prefect, let's import both this flow and this task. It detects that it's not installed yet, so I'm going to go ahead and hit install there. That's looking good. Great. That cell reran. Let's have a function over here called hello. Some sort of name goes in. It's going to return hello plus name. Let's have that be a task. And then below over here, let's have a flow. Let's call that main. And the only thing really happening here is that we're calling the hello function over there. But just like before, what we have over here is one function that's a task, and we have this one function that's a flow. And theoretically, at least, this should work, right? So I'm back in the terminal and I'm going to use a new command. I'm going to use the prefect deploy command. And this allows me to take a job that I've defined locally and to just really make the server aware of it. And doing so will also allow me to schedule it. I could say, well, run this every minute or every day or something like that. It's a clever tool too, because it's going to look around for Python files that might contain a prefect workflow. So just as a quick demonstration, I should be able to maybe select this quick demo.py file. That's the file that I started this video with. I'll just go ahead and select that. I'm just going to go through all the basic settings. One thing that's good to know is I also added a worker to my server. I did that off screen, but I'm going to say that I would like to maybe configure a schedule for this deployment. I'm going to say yes. I'm going to say that I want to do that with cron. And let's say that, let's just run this every minute just for demo purposes, right? I would like to activate this schedule. Yes. And let's not add anything else. That all seems fine. And if I now go back to my server, you can see that, hey, I'm able to add a flow over here. Here's that demo flow that I just added. I can see that a whole bunch of stuff got scheduled. So that's nice. It's not just that I'm able to run something from the command line and get some nice logs. No, I'm actually also able to use Prefect to also schedule all these workflows by uploading it to the server, basically via the command line like I just did. But let's now try to repeat this, but for the notebook that we just made. So we have this main flow in our first notebook.py file, and let's see what happens if I try to run it. There's going to be an error. And why is that? Well, it's having a hard time finding a flow function with the name main. And why might that be? Well, if we scroll down, the function in question that we're interested in is in a Python file, but it's nested. It's inside of this function over here, and that is making it hard for Prefect to, I think it's using AST under the hood, but it's making it hard for Prefect to find this main entry point over here. We did add a decorator, so it's able to understand that there is a entry point. It's just that it's not quote unquote maybe clever enough to also look at definitions inside of other functions. And honestly, I also can't blame them for it. So this is very unfortunate because I would really love it if I'm just able to define my workflows inside of a Marimo notebook, but using the default configuration, the way that Marimo puts your code into other functions might give you the impression that you can't do this. And that's not true though, because we can do a really cool trick. And it's a somewhat advanced feature of Marimo, which is why I'm so eager to show it, but it's especially useful if you're a Prefect user. So let's go back to this notebook and make a few changes. I'm back in the notebook now, and let me make this one change. I'm gonna pop open the command palette, and I'm gonna tell Marimo to add a setup cell. This is a special kind of cell. It is a cell that allows me to have global dependencies that pretty much all the other cells depend on. And I'm gonna just hit copy on this, and then I'm gonna paste it down here. And if everything goes well, you should be able to see an interesting change. The moment that I move this code into a setup cell, you will now also notice that these two cells down below over here become reusable. In short, that means that this notebook now has functions defined that you can actually import in other Python files or other notebooks. Because we are explicit about the dependencies that all the other cells need, we can state that this is a stateless function, so to say. We just have to make sure that the setup has to be done, but after that, we can actually export this. Now, to explain how all of this works, let me just add one extra function down below over here. Also, just for fun, let's just import polars in this cell over here. And the reason why I'm doing this is I want to have a cell around that is not a reusable cell. In this case, because this cell contains more than just a single function and is no longer a reusable cell, if you want to expose something to be reusable, the cell can contain one and only one thing, so one class or one function. In this case, there's more. I'm also doing an import here, but by adding this cell, we can now more easily compare what the difference is between a normal cell, a reusable function, and a setup cell. So let's now go back and inspect the Python file. So again, I installed polars, right? So we can see that that's been added as a dependency because I'm running this in sandbox mode. That's all very nice and good, but if we now have a look over here, we can see that instead of there being a cell that has all of these imports, we now see a context manager with app.setup. And from the perspective of the Python file, we are no longer inside of a function. So this is actually globally available information from the perspective of the rest of the Python file. Now, to take a bit of a step back, this is again what a normal cell looks like. We can see the contents of a cell over here, and we can see that it's been wrapped around by this function underscore that has this decorator attached. And for a lot of Python tools, it can be hard to detect declared functions inside of other functions. But these two functions over here, because we've got this setup cell around, which again exposes dependencies globally, we can do something clever. Namely, we can say, well, there's really only one function here. So let's just keep the function around as it's in the cell. and we're going to give it a different decorator instead. And by doing this, again, from the perspective of a Python file, we now have two functions at our disposal that are available as normal, and best of all, they still have the decorators that we attached to them. Now, if I were to do something like prefect deploy, I should be able to go to my first notebook.py file, and now when I select it, I can call this notebook demo, I can give it that worker, but notice how we don't get an error anymore, and that's because we are able to expose functions in our notebook. We're able to say, well, there's a couple of these functions in the notebook where all the dependencies are declared in the setup cell, but from there on, you're able to import those functions as you would normally. Again, because it's a normal Python file, and because in this case, we have a clever way to turn a cell into an actual function. So let's not configure a schedule for this just yet, right? But when I now go to this flows tabs over here, I can see that I had this demo that I had before, but I also see that I've got this main that I just added as well. We can see that there's a deployment as well. That's this demo notebook, and there are no runs, but we can definitely see that the metadata has been uploaded. And there's an entry point, first-notebook.py, and then the main function. So there you go. We now have a way to go from marimo notebook, making sure that we have functions that we expose, and then those can be decorated such that Prefect becomes aware of it. I figured it would be good to do one more demo that's a little bit more realistic and a little bit less hello world. So what I have over here is a notebook where I actually analyze some data. Again, like before, I've got a setup cell, so polars is going to be around, Prefect is also going to be around, and any functions that follow that use any of those imports, they become reusable functions. So I've got this one function over here that's going to read in some parquet. What does this cell need? Well, it needs polars around, and it needs this task decorator. Both of those two things, again, are in this setup cell. So there you go. This is a reusable function. And all the functions that I've got here are stateless. A data frame goes in, a data frame goes out. I've got one to set the types, another one to clean the data. This is for a data set where I'm dealing with logs of sessions, so I need a sessionization step as well. There's some adding features for machine learning. There's also a step that removes bots. And there's also a task here where I'm pretending to actually write to a database, which I'm not doing, but I figure it'd be fun to add that as well. And then all the way at the bottom over here, I have this flow. That's the entry point as far as Prefect is concerned. That has a Python function that contains a full pipeline where first I read a data set, then I add types, then I clean data. These, again, are all functions that are also tasks. So these should appear quite nicely in the Prefect dashboard when I start running this. And then all the way at the bottom over here, I'm using a cute Marimo feature. I'm able to ask Marimo in what mode it's running. And you can imagine that normally, as in what I'm doing right now, this is edit mode. That is when you've got cells and you're doing actual analysis. But you can also take the same notebook and just run that from the command line as you would normally. And then you are running this in script mode. So that means if I were to take this notebook and if I were to UV run it, then it's going to actually call this run pipeline function. And if this is declared as a workflow beforehand, which I've done, then if I were to run this from the command line, I should be able to see the effect inside of the server. I'm not going to do that. I'm just going to take this function as is. I'm just going to run it directly like so. I can see logs appear. If I then go to these runs over here, I can see the run pipeline flow. I can see that it's indeed running the read data function. That is now done. It's moving on to the next function and the next one and the next one. It's doing sessionization now. It's going to add machine learning features. It's going to pretend to write to a database, and it's removing bots, and it's pretending to write to a database one more time. And as all of this is happening, all the logs are appearing down below over here. I can click on any task that I like to zoom in. If anything fails here, I'll be able to see that as well. I have the cog just like before. I can maybe turn this into a dependency grid, maybe have more of a temporal view. And frankly, this is also something that I can schedule. So I have all the benefits of a Marimo notebook, and I also have all the benefits of Prefect, because in the end, both tools expect a Python file, and that is exactly what I'm dealing with here. So there you go. This is a really nice integration. And this now brings me to what I think is the real killer feature of this integration, because if you think about it, we can rethink the way that we write batch jobs. The real benefit of a Python notebook is that you have the interactivity. But it's only now that we're able to have a nice notebook environment that is also still a Python file. Having a Python file makes it easier to integrate with services like Prefect, but it's also easier to actually start thinking about it as a proper block of code. But you still get the interactivity. And that's incredibly useful when you're trying to debug in hindsight. But that also means that you can start writing your code of your batch job a little bit differently, because not only does it have to do something that's very functional, not only are you going to try to make it foolproof in production, but you can also write it in such a way that if something goes wrong, debugging is easier because, again, you have an interactive environment at your disposal. And as a final example, let me just show you what I mean by that. So again, I'm back in my notebook, and as you might notice, if you look at the code, you'll find that there are a lot of these if statements here that check if we are in edit mode. That is to say, this code over here will only run when I'm maybe debugging or when I'm building. It will not run when I'm running this in production with Prefect, and it also won't run if I run this from the command line. This will only run when I'm like doing interactive stuff. And that means that I can also maybe add some extra utilities. So this read data function on top over here, right? Let's go there. And let's say that I'm maybe interested in debugging this, then one thing that I might want to do is I might want to add a limit, and let's set that to none per default. And let's say that this data frame that I have over here, that's now a lazy Parquet file. Instead of loading everything into memory, we're just going to scan it real quick. And then if there's a limit, then we can say, well, let's just grab the last few rows, because those are probably going to be the most interesting for debugging, and only then collect it into memory. And that's the thing that is going to be returned. And if there's no limit set, well, then we're just going to run this as normal. We're going to run this over the whole data set. So df collect. But notice how this change over here, that's great for ergonomics if you're trying to debug, but this is something you probably wouldn't consider if this was a production workload. And it's that little nugget of, oh, I'm thinking a little bit differently about how I might want to use this code that gives you a lot of freedom. Because again, remember, these are reusable cells. So what you could even do is you could say, well, I've got this one notebook that also contains the batch job, but if I ever want to do a deep dive, well, then I'm just going to consider this notebook to be the place where all my functions are defined. It's also where some of my unit tests live. But then I have another notebook for larger analyses, and I can reuse the same code as well. And again, if you're used to Jupyter, these would simply not be things that you would consider. But with a Marimo notebook that actually stores everything as a Python file, you can. And that's, in my mind at least, the killer feature. By having tools that are Python first, like Prefect and Marimo, you can actually rethink the integration in ways that you couldn't if you simply had tools that weren't in the same programming environment. So there you go. This is why I think the integration between Prefect and Marimo is super nice, because they both just celebrate Python in the end. If you're curious to give this notebook a spin yourself, check the show notes, there's a link. Thanks for making it all the way to the end of this video. Feel free to like and subscribe, and stay tuned for more videos like this.